On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to talk about two types of discontinuities. You have removable and non-removable. And for removable, a way to think about it is, look at this little dot right here. It looks like a little dot. In this case, it's an open circle, but it looks like a dot has been removed from this line. And that's what a removable discontinuity is. If we could put a dot, if we could close that spot up and make the function continuous at this particular x value, in this case 2, we have a removable discontinuity. So visually, it's just a little tiny hole in a graph. That's what we call a removable discontinuity. What about non-removable? Non-removable is when replacing or putting a single dot somewhere on our curve. If we could make that function continuous, it's removable. But if we put a single dot anywhere around here, we cannot make this function continuous when x equals -3. Yes, you may see vertical asymptotes here. Those are examples of non-removable discontinuities. That's not the only type of non-removable discontinuity. There is another type that we will discuss right here briefly when we hit this part of the video. So again, we cannot put a dot anywhere around here. One dot. We cannot put it anywhere around here to make this function continuous at x equals -3. Now, with all that said, I do want you to bear in mind a lot of functions that you'll deal with in calculus are going to be continuous over their entire domain. An example here is the graph of cosine of x. But now let's talk about this a little bit more. This first one here, this removable discontinuity. A lot of times when you have like a rational function here, f of x, I'm going to factor that numerator as a difference of squares, x plus 2 times x minus 2. And what I'm going to do is I'm going to remove the only x minus 2 factor that I have in the denominator. As a matter of fact, it's the only factor we have, period. But we are removing that factor. Now, had we had another x minus 2 down here at the bottom, we are technically not removing all of those x minus 2 factors. But since I'm removing the only x minus 2 factor at the bottom, that's what's causing this hole to pop up. As a matter of fact, that's what's causing this graph to be a line, because all we're really left with is f of x. Once we simplify it, it's equal to x plus 2. Again, such that x cannot be equal to a positive 2, because notice, if we plug a 2 into here, we get a 0 in our denominator, and we can't divide by 0. So really, when we look at this graph here, all we have is a line with a slope of 1 and a y-intercept of 2, right? We're crossing the y-axis at 2. Our slope is 1. But notice x cannot be equal to 2. That's where our hole is, and we are removing that x minus 2 factor. Hence, removable discontinuity. Looking over here at g of x now, we cannot remove this x plus 3, so we have some funky stuff going on. This is actually, I guess you could consider this part an intro to vertical asymptotes. A full video on that coming later on in this series of videos, but we cannot remove that. Non-removable. And again, we cannot place a single dot anywhere here to make this function continuous. Again, h of x here equals cosine of x, continuous over its entire domain. But then let's talk about this last type of non-removable discontinuity. Vertical asymptotes, those are non-removable discontinuities. But here's another type of non-removable discontinuity, a piecewise function where you have a jump. Some people call this jump discontinuities, same thing as non-removable discontinuities. And the reason why is that we cannot place a single dot anywhere, one dot. You cannot place one dot anywhere to make this function continuous, at this case when x is equal to 1. So yes, vertical asymptotes, non-removable discontinuities, and some people refer to this as jump discontinuities, same thing as non-removable. And there you have it, the two types of discontinuities that you'll run across. Very important later on in your calculus course, where we start talking about differentiation, where one of the main rules for a function to be differentiable is that it has to be continuous at a particular point. So yeah, more on that later, but here are your two types of discontinuities, removable versus non-removable, and that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.